Good morning. My name is Kevin Kilgallen, and welcome to day 3 of our eFAB Expo. This is our virtual trade show that we're hosting to give you new ideas to help continue to grow your business. Today we're going to start off with HE&M saw. HE&M manufactures right here in America, American-made products for sawing the front end of every operation. So before I turn it over to Doug and Max Harris, I do want to make you aware of some swag that we have here at Mid-Atlantic, Southern States, and Northeast. So pretty cool shirts. Manufacturing makes America strong. So if you'd like some of our swag, just reach out to your salesman. The camo hats look great as we get and prepare for hunting season. So enjoy the presentation, and I'm going to turn this over to Doug and Max. Thank you.
Yep, go ahead.
Well, we appreciate you joining us today. We're going to go ahead and show you our manufacturing facility on how we build equipment, where we build it, and take you through the process. And then when we finish up, we'd like to answer any questions that anybody might have. If not, we prepared a few, which are common questions we get asked. Hello, I'm Doug Harris, President and CEO of HE&M saw. HE&M saw is a family-owned company, and we've been in business since 1964. It's the American dream. We started in the garage in Livermore, California, and we moved to Oklahoma in 1976. When we first moved here, we only had 12,000 square feet, but today we have over 300,000 square feet. And what I plan to do today is to take you on a tour through our East facility so we can take a look at how machines are made from the raw material till the end product. First thing that we have to do in the build process is start with raw material, and then we're going to saw it. And after it's sawed, we're going to take it to our machining centers. And that's the very beginning process of the build. Now I'm going to take you through the machining process. Here we have Jeff. Jeff is the manager of our East facility. He's over the machine shop in the fab shop, and Jeff is going to explain to you exactly what's going on here.
So this is a tabletop for our Lmdc saws, and what we'll do is we'll cut up all the pieces from raw stock form and then weld it up. After it's been welded up, we'll take it over to our Marasiki machine, our large vertical machine, set it up, fly cut the top, put tapped holes in it, and then inspect this piece for it to get fitted and welded again.
Very cool. Over here I see we have a tremendous amount of parts, just a ton of inventory. So Jeff, tell me about this.
So this is our staging area. So all the parts that are machined, bent, or saw cut will come over here to get staged, to get ready to be welded up. So this part over here is what it turns out to be after we get done kitting it. Take it over the weld shop and then weld it all up.
I see over here we have some flat stock. It looks like it's already been cut on the laser. So Jeff, go ahead and tell me about this process all the way through. Please explain it.
So over here, we take flat plate, put it on our laser, cut it to whatever we need to, whatever that print wants. And then what we're going to do is we'll lift it up, take it over here to our press brake, bend it, and then get it ready to be fitted and welded.
So I see these pieces, Jeff, over here. Looks like they've been lasered out, holes put in it, and then bent. Well, that's beautiful.
Yes.
And all made here in America. Jeff, I can see that this looks like it's already gone through the press brake. So tell me about this arm.
All right, so what we got here is we've got certain bent pieces and machine pieces. What we're going to do is we're going to fit all these parts up, tack it, and weld it up to our vertical saw.
Very cool. So Jeff, in looking at this arm, this is incredible, the size of all of this. So why don't you tell them a little bit about this one?
What we have here is a WF-160 arm column. And what Eric is doing here is he is making sure everything is level and straight. Once everything is level and straight, he's going to tack it up and weld it to be a final product for arm.
You can see he really takes a lot of pride in his work.
Oh, absolutely, because it's made in America.
Over here, we have our brand new paint facility. Everything in it is new to the process of building. And I see we have a giant booth down here. What are we doing there?
Yeah, so that's our paint booth. And what we'll do is we'll fit large parts in there, put them in, and paint them up so everything stays in there and nothing comes out and nobody gets hurt by the fumes.
Over here, what we have is a brand new paint line that we're putting in. What we have in that is automatic painting, and it's also furnaces to heat the materials and to dry the paint extremely quick. We hope to have this up and running by Q1 or Q2 of this next year. Over here is our electrical shop. Since we're vertically integrated, we build everything here for our customers and for our equipment. My son Max can go ahead and take you through what we are doing in here.
In here, we're a full UL 508A panel shop, so that allows us to fabricate our control systems. We have an electrical engineering department that's responsible for actually fabricating and designing some of our systems. We then also get into board work that we do for some of our older systems. We still fabricate the components.
It's important that when you have an older piece of equipment that you can get parts, as well as a newer piece of equipment that can be customized for your needs.
In front of us, I noticed we've got a lot of components pre-kitted and ready to go out to our equipment. In our warehouse, I also noticed we've got tens of thousands of parts ready and available for all of our equipment, both new and old.
Over here, we have our small machine build area. These are where we build the small pivot style machines. And to our right, we're building a material handling system. This is for one of our customers, for one of our larger machines that we'll take a look a little further on down the line. Over here, we have our vertical machine line. And Max, why don't you tell them a little bit about that?
So with the vertical machines, it allows for a double miter. So it's a 60-degree miters in two different directions. The reason for that is it allows us to do a lot more capability in a smaller package. With the vertical, you can retract the head, giving you a very good performance in terms of square footage, because now you can load on the machine and not worry about a lot of distance in front of it.
Max, tell them about the back. I can notice on this machine here, the spine on this machine is absolutely massive.
So the reason why we do that is we really want to have a structure that is capable of handling whatever loads you throw at it. The feed table on this machine is capable of loads in excess of 10,000 pounds. And because of that, that machine needs to be able to take those loadings and capacities. With this structure, it's really designed in a rigid format.
I see the gearboxes on the top. We use ball screws for the bar feeder, the same type of technology they use in machining centers, so we get machining centers type accuracy.
Yep. And with the gearbox on top, it really allows for a much better longevity because it keeps it out of the coolant and the chips.
Here is our inspection area. Before any HE&M saw gets shipped out, it goes through inspection. The air machines are run for 4 hours. The hydraulic machines are run for 8 hours. But Max is going to explain some of the details that we go through before we ship a piece of equipment.
So with our equipment, as Doug said, we make sure to run our equipment for a length of time so that we make sure that there are zero problems when it leaves. We want to dial in all of our carbides. We want to dial in all of our components, as well as make sure all the hoses are run right, all the electrical lines are run right, so that it meets our high quality standards that we do here at HEMSA.
After they're inspected, they're all wrapped and are ready to ship out on a truck. Because we do everything here at HEMSA, one of the things that we'll do is take an old piece of equipment, this is an old WF-160, and rebuild it. Many times we've had a customer either have a fire or a tornado hit their shop or something has happened, it's got caught in a flood. They'll send the piece of equipment back in, and because we build here in the USA, we're able to take a machine like this, go all the way through it, and when we're done, it looks like new.
Not only do we have the capability of rebuilding and remanufacturing equipment here at HEMSA, we also have a fantastic team of factory-trained service technicians located regionally throughout the U.S. This team is capable of going through and doing full installation, service, as well as preventative maintenance packages.
This is the V200. It's one of the larger saws that we build. It's our biggest mitering vertical. This is building 10, and building 10 is where we build our extremely large saws. This saw right here, when it's complete, will have a full material handling system with it. Max, go ahead and tell them a little bit about it.
So this structure here, as you can see, we have the gearbox on the top, which really allows for that same design philosophy as we have on our smaller machines. Real heavy-duty C-frame construction gives a very good performance, and it also comes with a touchscreen built in. This way you can go through and not have to worry about dialing in those miters. You can just have it move to the position. And because we design our equipment with the material handling in mind, we're even able to incorporate all of that directly into the same control structure. So it's just as simple as moving a switch.
The nice thing about it is everything is designed and built, so integration is very easy. We take care of it from start to finish, including the material handling system. Here is our H90A-1. This machine right here is an absolutely tried and true tested machine. We have thousands and thousands of them out in the field. Max, go ahead and tell them about a little bit of the features and functions and benefits.
With this machine, we've got two cylinders here. One cylinder for control, one cylinder to keep the counterbalance of the head. So really, this structure is a very, very solid, well-performing control. This A-1 is one of our most tried and true tested structures. It just performs day in and day out. We even have safety-rated door switches because here at HEMSA, our #1 priority is safety, and you'll see it across the line of our equipment.
Yeah, safety is very important to us at HEMSA. We want to make sure that we produce a piece of equipment that keeps your employees from getting hurt. Safety is our #1 concern here. Here we have our V100 LM3. This is a really nice package for a small vertical machine capable of mitering 45 in both directions. Max, why don't you tell them a little bit about this machine?
So with this machine, we've got the gearbox on top, as you've seen in all of our other verticals. And again, that's just allowing a much longer longevity of the components. We also have LED readouts for blade speed and tilt angle, making it easy for operators to set up the equipment.
That's great. Now over here we have our VT140 HA60 CTS. So what does the CTS stand for, Max?
So the CTS stands for Computer Controlled Feed with a Touchscreen. The computer in this case is a PLC. With this, you get the ECT as well as the full ability to do automated jobs. You can do anything from a part to a series, allowing for easy setups.
The nice thing about this machine, with the ECT, it'll automatically control now the head coming forward and the amount of pressure. So we have things set up. So when you pull up that job, it'll automatically set the feed and the speed of everything coming through to cut. Plus, it's icon driven, when you have it on that touch screen.
So all you need to worry about is what material it is. The operator can press that material, and that's the full setup process.
It's a wonderful way to do it. It makes it very easy for the operator.
The other thing that we've added to this structure is two-hand control. And again, coming back to safety, everything we want to make it easy for the system as well as safe as possible.
Yes, because one of the things that we've learned over the years, if you keep the operators away from where the blade is and he starts the machine, they're much more safety conscious. The last thing we want is anybody to ever get hurt on our equipment. Here we have the WF-130 machine. WF stands for wide flange. And what I mean by wide flange, it was all designed around cutting wide flange beams and bundles of material. And this one here also has a very unique bar feeder. And Max is going to explain it to you.
So this is a full roller ball screw table. This is the same type of table that we have over on the verticals, just with full material support. Same high-speed capacity, same full performance of it. We also include a safety pull rope to make sure that it keeps the operators out of that crash hazard.
Yeah, also remember, these have twin ball screws, keeping that feed mechanism extremely rigid and accurate as it moves forward and back. On the front of the machine, you can see we have a very aggressive cant on the blade. That's extremely important when you're cutting those really large beams. Bidirectional vices as well for bundles of materials to easily pass through.
The control structure is the same type of control structure you get on the verticals. Same interface, so an operator that can operate our vertical machines can operate our horizontal machines. We try to keep it very consistent across our lines.
Over here is our WF-190 Lmdc. As you can see, this is really a big bad boy. Think of the WF-130 that you saw blown up. It's a very heavy-duty machine for heavy-duty cutting, for either wide flange beams or for bundles of material. Max is going to take you through a few of the features on this machine.
Just like in the smaller WFs, it's got the same cant on the head. That's achieved through one large wheel and one small wheel. It's a very unique feature across our machines. We also run the bidirectional vices, allowing it to get out of the way of any strapping or bands that may be on the material. Really, it's a very high-performing structure.
And it is, and one of the other things that we're extremely proud of is made in the USA. And that's one of the reasons we wanted you to see our company and what we do. We're very proud of Made in the USA, and we're also equally proud of Workshop for Warriors. HEMSA has been a supporter of Workshop for Warriors for many, many years. And what they do is when people come back out of the military, they need to transition for civilian skills. That could be either a welder or a machinist or a draftsperson or a designer. Workshops for Warriors is where they get training, and we're a very proud sponsor of them. Now we're in our research and development area. This area here, we're doing a lot of development work since we have an extensive engineering staff here at HEMSA. This is a double column machine that we're doing a lot of specialty things to the machine to make it a better piece of equipment. Over here we have a new prototype vertical we're working on. Max is going to tell you about a couple of the new features and functions that we're doing on this new machine.
Because this machine is designed around exotic materials and hard to cut materials, we've got a couple of unique features. The first of it is the active cut watcher. We got a patent a couple of years ago which really allows us to increase the band tension while we're detecting deviation, allowing us to get a longer blade life and better performance. The other side of things is a blade enhancer. And with this blade enhancer, it really gives great performance because it allows us to rock the blade in the material. Very similar to what some of the blade manufacturers call a sinusoidal blade. And with that, it gives great performance in exotics. It just takes a different attack angle.
We've also designed an extremely heavy-duty bar feeder on this machine. It's capable of moving 20,000-pound loads extremely fast. The new control designs are allowing us to take some of our old technology and push it to some extreme limits today, really increasing the performance of this equipment. Thank you very much for taking this tour and seeing what we do here at HEMSA. We felt it's really important that you see we really do it from the very beginning to the very end of the build process. We do it here, and it's made in the USA. I'd like to go ahead and turn this over to my son Max and let him give a few of his feelings.
Thank you guys for joining us. It's really been an honor to show our facilities off to you guys. And then we'll be here to answer any questions that you may have. If you come up with any questions after the Q&A session is over, please feel free to reach out at hemsaw.com.
Remember, proudly made in the USA. I'll do.
Welcome to reach out at hemsaw.com.
Gotta remember to suck my gut in.
We'll crop it, don't worry.
Well, I hope you've enjoyed the tour. We had an awful lot of fun making this video. We'd like to answer any questions anybody might have. If not, what we can do is we've prepared a few questions that we get asked all the time.
All right, well, that was great. Thanks so much, Doug. I have the first question here for you. So let's see. Just a second. All right, so it says, hey, Doug and Max, Mitch Bruker from eFAB Machinery. I noticed that in all of your vertical saws, you mentioned that the gearbox is located at the top of the arm of the saw. What are some of the advantages of this design?
What led us to that is when we first started building vertical saws many years ago, we realized where all of the coolant and the chips fall is straight down. And one of the problems with that is if you ever have an issue with the gearbox seal and you roll it one direction or you roll it the other direction, the oil will leak out. And, and trying to keep all the contaminants out of it is extremely difficult. So we saw a real increase in longevity on the equipment by doing that. It made it much more trouble-free. Once it's up on the tops, I always joke with people, I've never seen coolant raise. It always comes straight down. Same thing with gravity with the chips. It's been a very successful design. It's given us a tremendous longevity in the equipment. So that's really the reason that we did it. It was just to protect everything.
Great, thank you. It looks like the next question we have here is, do you make a fully automatic WF-190?
Yes, we do. You can get up to a 10-foot bar feeder onto it. Once again, we'll use dual ball screws. We've tied that in some of our material handling system. It moves at an extremely fast rate. Max, what kind of rate are we getting out of that?
So typically with the 120 inch, we run it right around 20 feet a minute with the ball screw table. If you're running the 48 inch table, because you're running smaller screws, we're able to get it up to 30 feet a minute moving material. And then in retract, we can get the bar feeder moving at 50 feet a minute without material.
One of the advantages, if you go with a 10-footer, it allows you to step feed. And what I mean by that, let's just say you were cutting 1-foot parts out of a piece of material that is 10 feet long. It'll just move 1 foot, then another foot, then another foot. It's not moving back to reposition the bar feeder. Once again, twin screw bar feeders, we get real tight accuracies with it. For a lot of people doing beam work and bundle work, absolutely love it.
Okay, thank you. And it looks like this is the last question that we have time for today, which is, what would be a typical turnaround time to rebuild a 1994 H100A?
Oh boy. It's going to really depend on the condition that we receive it. And, you know, if the machine's been very well taken care of, you know, typically on something like that, it will depend on what level they want us to rebuild it. If they want us to tear it all the way down to bare metal and rebuild it all the way up, obviously that would take longer. If they would like us just to go through it, anything that just needs to be replaced, we replace it in turn and make sure everything else is in good operating order. Don't repaint the machine. You know, that we can turn around in generally about 3 weeks, up to 4 weeks.
Great. Well, thank you so much, Max and Doug and everybody at HEMSAW. That was excellent. We really enjoyed that presentation. We just thank you for being with us today. Unfortunately, that is all the time that we have, but if you did not get your questions answered, you will receive a link in your email to schedule a session with HEMSAW. And our next session is Flex CNC at 10:30. But again, thank you all for being here, and thank you so much, Doug and Max.
Yeah, thank you for the opportunity. We greatly appreciate it.
All right, thanks, guys.